Hi, in this video, I'll show you how to use the normal distribution table to compute the Z star in the calculation of a confidence interval margin of error. Okay, so let's take a look at this problem. Compute Z star for a 93% confidence interval. All right, so for a confidence interval, the representation on a normal distribution is like this, with the confidence level being an area in the center of the standard normal curve. Okay, so that's what happens if we take the confidence interval in the problem and we take the z-score of it. Then the endpoint of the confidence interval will become this z-star number, and we're asked what it's equal to. Okay, so we're gonna use a normal table for this. So let's take a look at the normal table. All right, so here's a normal table, the normal table, one part of it. Here's the z for the negative side, and you notice that for the normal table, the area that's given is always completely to the left of z. We're not missing anything. We get the complete area to the left of z, okay? So for example, if z were negative 2.93, then this area right here is the complete area to the left of z. And it's the same thing for the positive side. For the positive side, here's the z, and what we get is the complete area to the left of that z. Excuse me. So in other words, if you're going to use this table, you need to make your diagram the same as the diagram for the table, which is the area to the left of z has to be all of it. So let's take a look at what we have. This is what we have. What we have, the area that we're shading is not completely to the left of the z that we're looking for. The complete area to the left of z would cover more than just the shaded part. If we want to be the same as the diagram in the table, then we need the complete area to the left of z, okay? So that means the first thing we need to do is we need to compute the area to the left of z star. So we have the area 0.93 or 93% in the middle, okay? That means we have 1 minus 0.93 as the area of both tails. Okay. 1 minus 0.93, now it's a decimal number, but for this kind of thing, if you want to calculate quickly, you may want to calculate using using percentages. So instead of thinking of it as 1 minus 0.93, you think of it as 100% minus 93%. So that leaves 7% outside, 7% in the area of both tails. That's 0.07. And I want just this area, just one area of one tail. So I divide it by 2, 0.07 divide by 2, 7% divided by 2 is 3.5%. Okay. So this over here is 0.035. There's another 0.035 here, which we are not using. All right. So I need the area to the left of z, area to the left, is equal to the 0.035 plus the 0.93. 0.035 plus 0.93, and that makes it 0.965. So I have the area to the left of Z. Okay. Now my diagram, now my normal diagram and the normal diagram in the normal table are similar or equivalent. So that means I can start looking in the normal table for the area that's closest to my area to the left. All right, so let's go looking for the area 0.965. Okay, that's my area. Here's a table. Let's go looking for 0.965. I'm looking for the area of 0.965, so I'm looking for the area in the body of the table as well. I'm not looking on the edges. The edges correspond to the numbers along here. The body of the table corresponds to the body of the graph. So since 0.965 is part of the body of the graph, I'm gonna go looking for 0.965 in the body of the table. The numbers here are pretty much in numerical order. So 0.965. Okay, I don't have 0.965, but I have 0.9649. So that's the closest. Okay, so here's what happens. If you find something that's closest, you go for that one. Okay, but if you're looking for something and you find a number that's sort of halfway in between, half and half, okay. So for example, if you're looking for 0.878 and you find two numbers, 0.877 and 0.879, then just split the difference, okay? This one is 1.16 and this is 1.17. So if you're looking for 0.878 as the area, then just split the difference and call it 1.165, okay? So that is if you're looking for that, right? But I'm looking for 0.965 and I don't have that situation here. I don't have a situation of splitting the difference here. I have the situation where this number 0.9649 is a whole lot closer to 0.965 than 0.9656. So I'm just gonna go for 0.9649. So in my notes, I'll write down that I found 0.9649, which is the area closest to my area. So step 3 is based on that, I'm gonna read off Z star from the table. I go to the table, I have my 0.9649, and I look on the edges for the Z, I get 1.8, and up here the second decimal is 1, okay? So Z star is 1.81. Z star is equal to 1.81, okay? This number, the official name of it is the two-tailed critical value. Okay. And another notation for it is Z with a subscript of alpha over 2. But I'd rather just use Z star because it's less confusing that way. All right? Okay. That's it. Thanks for watching. Bye.